Anti-aliasing diagnostic. In XSI version 4.0, under the either region options or render options, there's a diagnostic mode tab. There's a particular option I would like to demonstrate here is the view sampling. This option allows you to view the actual samples that is actually being taken. So for every dot that you see, this is actually ray being casted in a scene. So as you can see right now, it's pretty much sending evenly distributed rays. So it's not really what we call adaptive. So it's not picking up the detail. So it's not spending more time where there's detail. So in this case, it's evenly sampling the actual rendered image to grasp and render the final pixel. So I've enabled the view sample here, and I'll go under the anti-aliasing tab and start to demonstrate what this feature is all about. Whenever the minimum and maximum are set to the same value, there's no adaptive sampling being done at all. So this parameter threshold is not being used. So even though you set it to 0, now you could see that every pixel gets a white pixel, which means it's basically a sample. So that's why you see all the image being white, because every pixel has a sample, and the actual sampling is being demonstrated by a white pixel. The grid line here is simply just to show you an actual tiling display where the actual tiles is going to be. So if I go here under optimization and change, for example, the tile size 32, for example, or even 64, and then press refresh, well, I'm sorry, 188, then you see the actual tiles being done. So these lines are what we call tile edge. I'll leave it to automatic for now because I really want to see what this thing is doing. And it's also, by the way, it's really suggested that you leave this thing to automatic. In some cases, you can actually degrade the rendering time and lower the rendering time or increase the rendering time depending on what value and what condition you use. So I really suggest that for now you leave it automatic unless you really have a situation where you need it, and those situations will be during the displacement map. So I suggest that you watch the displacement map AVIs, and the actual tile is going to be explained over there. So let's go back to anti-aliasing. So as you can see, setting the minimum and maximum value to the very same value obviously evenly distribute pixels, so it's not doing any adaptive work. So I'm going to lower it a little bit, like -20. So it's going to evenly sample the actual rendered image, but it's going to spend a little bit more time where there's actually noise details. So if we go back here and disable the image right here, you could see that it's actually starting to pick up details where there's actually color variation or black. But still, this is not high quality, as you could see. So it's doing a little bit of adaptive sampling. So if I start to lower this, I'll be starting to increase the detail pickup that occurs. So whenever I'm more like tower, like when the threshold is more like towards 1, well, the actual rendering tends to be more like around -2. So when lowering the threshold value towards 0, you increase and you force the engine to actually sample more towards the max level. So if I make it very, very, very small, then obviously now it's really doing a good adaptive render. Let's go back to the non-diagnostic mode. That's pretty good, and that renders quite fast actually. So now we're still actually not doing any what we call oversampling or super sampling. Well, still the minimum a pixel will be sampled at least once. Otherwise, the rest, like here, these are basically pixel being skipped because there's no really color variation. So I'm going to increase this slightly here, and now you could see that we're starting really to pick up pixel underneath. The reason why you see this color change or shading changes, it means that now a pixel contains either black pixel or white pixel. So it started to look like a little bit like gray when it's combining the actual final image. So it's basically replacing the actual subsamples or the actual sample by either a black subpixel or a white subpixel. So white subpixel means that the actual subpixel has been sampled, black means it has been skipped and then no sample has been done. So now you can see now it's really starting to pick up the details. So I could pretty much go back to 1 here and I'll be missing a lot of details. So even though you set it to 1, which is normally if the actual threshold was really low, would pick up to 4 samples per pixel. Even because the threshold is so high, it won't go that deep, or it will basically stop and rather stay more like -2, -1. So these are pretty much -2. This one start to be -1, even 0. So it's not even starting up to go towards more like 1. So as we start to lower it, we're starting to pick up. So these here start to go into the super sampling, more like towards 1. So we'll start to lower this like this. That sounds like pretty good. It's rendering still quite fast, and obviously the quality is going to be there. So the view diagnostic mode is simply a way to see the actual sampling being done and visually see where the time is being spent in the image. So the brighter or more white is the actual diagnostic, then more work is being done. Something also I would suggest is to use what we call diff pick -i to compare two images in order to see if they differ. So if you have two anti-aliasing settings, one that renders a little bit slower and one that renders faster, and you want to see, well, they look the same, but I really want to make sure that these two, don't differ too much, because I want to make sure in the final stage I don't get surprises popping or shimmering and stuff like that. So it is very difficult actually to see it on screen. So what I suggest here is to go here under a database. So I'm going to go here, go under databases, XSI, I'm sorry. So let me see, DVD. Voila. Now I've rendered already these images for you. So this is part of the database that came with these AVI. So I'm going to show you how to actually do a diff between two different renders. So we have here a let's say, let me see here, we have the maximum quality and we have the improve. Okay, so let's say for example this one maximum quality is really a high density. So let's go back to the slide here. These are the images. What you see in the actual command line here is basically these images. In this case we have a very high quality in this case, so it's 0 to 3, a threshold of 0.3, which is very fine. So it's going to actually, it's really going to go towards like 64 sample per pixel. This takes about a second to render for each tile, which is kind of slow. If I've used the actual adaptive sampling here, and I basically lower the min and max and adapt the threshold to 0.1, I'll cut down the rendering time almost by half or even more, and that will speed up. And if you do a intensity comparison between the two, you see that actually there's no visual differences between the two. So now you just save probably 50% of the rendering time just by doing this tweaking, and you don't see a visual difference. So this is the diagnostic output for this one and this one, and that gives you an idea of what it should look like. Now when you're starting to get really fine details and stuff like that, it's picking probably way too much. This is pretty much a very good diagnostic that you should see. this image here, just to prove you that there's actually a difference, is like the luminosity is so low that I went through a painting program and basically play with what we call levels to be able to show that actually there is a difference, but the actual difference is not visible because the intensity difference between the two images is not perceptible. You won't be able to see it. So if I go back here and I do diff pick -I, and -I stands for intensity, so I could pretty much say I want to use vein improve and vein quality max. If I don't provide an output -O, then obviously it will basically print it on screen. So as you can see here between the two, but keep in mind on your final media, whatever it's digital or films or whatever, I doubt these kind of details will show up, and we'll basically see, well, there's a huge difference between the two. So you just save a lot of time and also without compromising on quality. So this is anti-aliasing diagnostic, and I hope you'll use it because it will improve your rendering time.